We are starting with types of symmetric systems that we are already working on it. I mean, we have gone through two types of symmetric algorithms. One was actually your I mean to say that block ciphers and the stream ciphers, and we have discussed in detail regarding how the block ciphers do work and how the stream cipher works. And then in the last, we have discussed regarding how we are going to implement hybrid encryption scheme, right? Now today we are going to learn about different types of symmetric systems, right? Types of symmetric systems. So there are several types of symmetric algorithms are being used today. They have different methods of providing encryption and decryption functionality. The one thing they all have in common is that they are symmetric algorithms, meaning the sender and receiver are using two instances of the same key. In this section, we will be walking through the symmetric algorithms and their characteristics, right? Now, the thing is that we know about the symmetric algorithm. Symmetric algorithm, the basic quality of a symmetric algorithm is it works for the same key at the sender end as well as at the receiver's end, right? This is the basic criteria for the working of your symmetric algorithm. So there are symmetric algorithms. I mean, these are the types of symmetric algorithms that we have discussed. Data encryption standard we have discussed. We have discussed triple dash. I mean, not we have discussed, but these are the types of symmetric algorithms. I mean, data encryption standard, triple dash, blowfish, two fish, idea that is called as your international data encryption algorithm, RC4, RC5, RC6, advanced encryption standard, Cipher, or that is called as your secure and fast encryption algorithm, encryption routine, and then serpent. Serpent, right? So these are the symmetric algorithms which are being used, I mean to say that in our symmetric algorithms, right? We have the data encryption standard. NSA announced in 1986 that as of January 1980, the agency would no longer endorse DES and that DES-based products would no longer fall under the compliance with Federal Standard 1027. The NSA felt that because DES had been so popular for so long, it would surely be targeted for penetration and become useless as an official standard. Now, actually, we are discussing now regarding different types of standards which are being used in symmetric algorithms. Now, DES was the first one. Now, actually, what was the problem with DES? DES was announced in 1986 by NSA, and in January 1988, the agency would no longer endorse DES. The reason was DES was compromised by a certain set of people, right? I mean, they have broken that particular algorithm. Because of that, DES was no more being used in nowadays, right? So the NSA felt that because DES had been so popular for so long, it would surely be targeted for penetration and become useless as an official standard, right? That was the main reason, so that DES is no more being used nowadays. So in 1998, the Electronic Frontier Foundation built a computer system for $250,000 that broke DES in 3 days by using a brute force attack against the key space. Now see, it contained 1536 microprocessors running at 40 megahertz, which performed 60 million test decryption per second per chip, right? Now, this was the problem with DES. I mean, how the DES was broken. The desk was broken in 1998. There was a company that was being called as Electronic Frontier Foundation that was built. They have designed a computer system, or they have, I mean, manufactured a computer system of $250,000 at that time. I mean, we are talking about 1998, and they have broken that particular desk symmetric algorithm in just 3 days, right? They have just taken 3 days and they have applied a brute force attack and they have compromised that particular algorithm. I mean, against their key spaces or like that. So what that computer contains, contains at that time 1536 microprocessor that might be running at the speed of 40 megahertz, right? They might perform 60 million test decryptions per second per chip, right? So this is the speed of the computer which was actually processing this particular, I mean to say the algorithm. I mean, brute force attack was being launched over that particular, I mean to say that algo, and that was compromised within 3 days, right? But for that, they have designed a special computer with high number of processors and high number of, I mean to say that storage requirement and all that, right? Although most people do not have these types of system to conduct such attacks, as Moore's law holds true and microprocessor increase in processing power, this type of attack will become more feasible for their average attacker, right? So this brought about triple dash, which provides stronger protection as discussed later in the chapter. Now see, I mean to say that many people, they do not have such type of computers at their home, but we do not have to, I mean, think in this way that, I mean, around 1998, these computers were the special computer. But nowadays, this was a very normal machine. I mean, now everything would be available in gigahertz or terahertz, right? So if we think that if now or today we do have the desk, I mean to say that algorithm, we can compromise in seconds because we have a lot of machines, we have a lot of high processing machines which are being available to everybody, and they are being available at every home, right? So anybody can apply a brute force attack and can easily compromise that particular computer. But when we are talking about the 1998 or that particular era, for that particular time, these computers were not easily available to everybody, right? So this brought about triple dash, which provides stronger protection as discussed later in the chapter, right? So to overcome this particular problem, they have designed an other symmetric encryption algorithm that was being called as your triple dash. I think I have given you the idea of dash and triple dash previously, that why dash is being called as triple dash. उसका रीजन है वो मैं आपको आगे चल के बताता हूँ, लेकिन मैंने प्रीवियसली भी आपको बताया कि हम ट्रिपल डैश क्यों यूज करते हैं, राइट? So dash was later replaced by regional algorithm as the advanced encryption standard by NIST. This means that regional is the new approved method of encrypting sensitive but unclassified information for the US government. It has been accepted by and is widely used. Actually, DES, after that, it was being replaced by regional algorithm as the advanced encryption standard. So we have replaced DES by advanced encryption standard. Why we have replaced? Because DES was compromised, right? And that algorithm was previously called as regional, and then the next version or the approved version of that was called as your AES, right? Now, how does the DES works? DES is a symmetric block encryption algorithm when 64-bit blocks of plain text go in, 64-bit block of ciphertext come out, right? It is also a symmetric algorithm, meaning the same key is used for encryption and decryption. It uses a 64-bit key, 56-bit makeup for the true key, and 8 bits are being used for the parity. Now see, in this particular slide, you are going to learn how does the DES work. अब डैश आपके पास कैसे काम करता है, ठीक है? लेट्स सपोज इट वर्क्स ऑन, इट्स अ ब्लॉक साइफर एल्गोरिथम और ब्लॉक इंक्रिप्शन एल्गोरिथम, ठीक है? 64 बिट का आपके पास ब्लॉक एज अ प्लेन टेक्स्ट आएगा और 64 बिट का आपको साइफर टेक्स्ट बाहर मिलेगा इसके, ठीक है? सो इट इज अ सिमेट्रिक एल्गोरिथम, राइट? मीनिंग दैट द सेम की इज बीइंग यूज्ड फॉर इंक्रिप्शन एंड डिक्रिप्शन, एज वी आर वेरी मच क्लियर रिगार्डिंग दिस पर्टिकुलर कॉन्सेप्ट कि जी व्हेन वी आर टॉकिंग अबाउट अ सिमेट्रिक एल्गोरिथम, दिस मींस दैट you are, I mean to say that a single key would be used at both the ends, right? So I mean, if we are using 64-bit key, 56-bit would be make up the true key and 8 bits are being used for the parity, right? Now how does it works? It works like when the DES algorithm is applied to a data, it divides the message into blocks and operates on them one at a time, right? The same like a block cipher, you are going to divide the message into different blocks, and every block is being operated by certain sort of key, right? The blocks are put through 16 rounds of transposition and substitution function. Now just imagine, I mean, I have told you yesterday what is the role of substitution and transposition. Actually, we are going to make our data jumbled and transposed in such a way that a normal person cannot know about the information that is being traveling or that is being encrypted, right? तो cipher text आपका जो बनता है 16 rounds of transpositions और substitution function perform होते हैं, and then your data is being encrypted. right? So the order and type of transpositions and substitution functions depends upon the value of the key used with the algorithm. अच्छा जी, दूसरी चीज जो आपके substitution और transposition functions perform होते हैं, that totally depends upon the key that you are using with that particular algorithm. If you have the larger key size, you have the more transposition and substitution function will be performed and your data will be more secure. And if you have the lesser number of key or a smaller number of key or a smaller key space, it might be the possibility you have the lesser number of transposition and substitution functions are being performed and you have the less security for your data. So the result is 64-bit block of ciphertext, right? So this is how your DES algorithm are going to work, right? Now, I mean, what does it mean when an algorithm is broken? Guys, are you listening me? I mean, everything is clear? Getting me or not?
Yes, sir.
Okay. So I mean, अब हमने यहाँ पे देखना है कि हमारे पास when I used to say your algorithm is going to broke, इसका मतलब क्या होता है कि मैं most of the time I would like to say that dash has been broken, AES has been broken. What does it mean? उसका मतलब क्या हुआ? ठीक है जी. In most instances, an algorithm is broken if someone is able to uncover a key that was used during an encryption process. Try to understand this particular concept. I mean, आप कब कहेंगे कि आपका algorithm break हो चुका है? It means that when your key is being exposed and it is being available to everybody, this means that your algorithm has been broken. So let's say Ali encrypted a message and sent it to Bilal. Zahir captures this encrypted message and carries out a brute force attack on it, which means that he tries to decrypt the message with different keys until he uncovers the right one. Once he identifies this key, the algorithm is considered to be broken. So does that mean the algorithm is worthless? Now, this is just an example. I mean, दो बंदे हैं, there are two people, Ali and Bilal. They want to communicate by using certain sort of symmetric algorithm. Ali has encrypted the message and sent it to Bilal. In between, Zahir has intercepted that communication. ठीक है, उसने intercept की, and then what he did, he is going to apply certain sort of brute force attack in order to अनकवर दैट इन्फॉर्मेशन. अब देखें, वो तो आपका इनक्रिप्टेड टेक्स्ट है जो ट्रैवल कर रहा है नेटवर्क के ऊपर बिटवीन अली एंड बिलाल, उसको जहीर ने इंटरसेप्ट करने की कोशिश की. नाउ व्हाट एक्चुअली जहीर वांट्स टू फाइंड फ्रॉम दैट पर्टिकुलर इनक्रिप्टेड टेक्स्ट, एक्चुअली ही हैज टू फाइंड द की. I mean, if he knows that particular key, definitely he would broke that particular algorithm. ठीक है, तो अब वो brute force attack apply करेगा and he has to use different versions of keys or from the key space. He will try first, second, third, fourth, fifth by using certain crypto system. Not himself. आप manually उस पे apply नहीं करेंगे, लेकिन आप by using any crypto system, you have to apply these particular keys over that particular encrypted value. And once your encrypted text is being decrypted, this means that that key is the right key that has been applied over there. ठीक है जी. अब आपने different keys को try किया पूरे key space में से और एक key आपकी लगे, this means that आपका algorithm break हो गया. अब this is the right key, you can decrypt the information and you can see what has been sent by Ali to Bilal, right? Fine. तो इसका मतलब ये हुआ, अगर आपका algorithm break हो गया है तो does it means algorithm is worthless? This is a question that he's been asking. यदि अगर एक एल्गोरिथम आपका ब्रेक हो जाता है तो इसका मतलब ये है कि वो यूजलेस हो गया. Now we need to I need to give you the answer of this particular question in the next few slides. So if an algorithm is broken through a brute force attack, this just means that attacker identified the one key that was used for an instance of encryption. इसका मतलब ये हुआ कि अगर आपका एल्गो ब्रेक हुआ है, इसका मतलब ये है कि अटैकर ने या इवल डूअर जो है उसने आपके पास उस पर्टिकुलर सेशन की या उस पर्टिकुलर जो लिंक क्रिएट हुआ है उसकी की उसने ढूंढ ली है. ठीक है, अब जब तक की उसके पास है, जब तक वो की चेंज नहीं होती तब तक आपके पास वो उसका रहेगा, जो भी इंफॉर्मेशन जाएगी उसको वो रीड कर सकते हैं. ठीक है, बट इन प्रॉपर इंप्लीमेंटेशन वी शुड बी encrypting data with session keys which are good only for the one session. So even if the attacker uncovers one session key, it may be useless to the attacker, in which case he now has to work on identify a new session key. अब इसका solution, now this is very important to understand. अब हम क्या करते हैं कि we are going to generate keys for a particular session. I mean, you people are well aware about DHCP, Dynamic Host Configuration Protocol. If we are going to give static IP to a computer, if your computer would be compromised with that particular static IP, then it would remain compromised until you are going to change an IP address. ठीक है, static automatically change नहीं होती, ठीक है. But if you are going to set DHCP server inside the network and all the IPs are being assigned by the DHCP, and after 5 minutes or whatsoever the time that you have set for those particular IP addresses, अगर आपके पास वो IP change होती है for every 5 minutes, let's assume that कि after 5 minutes आपका DHCP server जो है आपके कंप्यूटर को new IP assign करता है. Now let's suppose an attacker has compromised that computer, उसकी आईपी उसको पता चल गई, उसने उसको कॉम्प्रोमाइज कर लिया, बट दैट कॉम्प्रोमाइज विल रिमेन ओनली फॉर 5 मिनट्स बिकॉज आफ्टर 5 मिनट्स अ न्यू आईपी वुड बी असाइंड. अब उसको उतना वर्क फैक्टर और लगाना पड़ेगा फॉर अनदर 5 मिनट्स. अब इस तरह से हर 5 मिनट के बाद अगर आईपी चेंज हो रही है तो एवरी टाइम ही हैज टू अप्लाई the same work factor that he has used for the first time. So can you imagine how difficult it is when your DHCP is being installed and it is going to secure your networks, right? So the same concept is there. I mean, if you, अगर आपके पास सिमेट्रिक की है, एक ही सिमेट्रिक की, राइट, उस सिमेट्रिक की को कॉम्प्रोमाइज कर लिया आपने तो पूरे का पूरा सेशन कॉम्प्रोमाइज हो जाएगा. नाउ इट वुड बी वेरी डिफिकल्ट टू रिकवर दैट पर्टिकुलर की. लेकिन अगर आपने डिफरेंट सेशंस की बना दी है, आई मीन फॉर फर्स्ट सेशन this key would be used, for the second session a new key, for third session another key would be used, then it would be very easy, it would be very difficult for an attacker or an evildoer to overcome that particular problem. Let's suppose उसने first session को compromise किया या उसने उसको उसकी की को ना अनरिवील कर लिया, ठीक है. अब क्या होगा, जैसे ही कुछ सेकंड के बाद सेकंड सेशन आएगा तो वो फर्स्ट की जो है वो अनअवेलेबल हो जाएगी या उसका कोई यूज ही नहीं होगा. फॉर द सेकंड सेशन ही हैज टू अप्लाई द सेम वर्क फैक्टर टू ब्रोक दैट पर्टिकुलर की और ब्रोक दैट पर्टिकुलर एल्गोरिथम एंड सो ऑन. सो डेफिनेटली द टाइम विल कम व्हेन ही वुड बी फेड अप to again and again apply the same to say that the work factor for every session, then he would be fed up and he would leave that particular computer to say that algorithm, because it would be very difficult for him to apply again and again the same factor for every session, or session maybe within seconds change हो रहा है, ठीक है. तो this is how you are going to secure your algorithm by implementing session encryption or session key encryption. Breaking an algorithm can take place through brute force attack or by identifying weaknesses in the algorithm itself. Brute force attacks have increased in potency because of the increased processing capacity of computers today, right? I mean, how can you break the algorithm? If there is certain sort of vulnerability inside your algorithm, or you can apply the same by applying a brute force attack. Brute force attack का मतलब पता है ना, hit and trial method. I mean, let's suppose आपने किसी का पासवर्ड हैक करना है तो आप क्या करेंगे, आप उसके जितने भी वर्जन्स हैं, जितने आप if you think that कि जी ये पासवर्ड रख सकता है, you will try from one to all. I mean, जो लग गया और नहीं लगा तो that's fine. But if you have to try कि जी ये बंदा कौन कौन से पासवर्ड्स रख सकता है, आप ट्राई करेंगे. अगर वो लग जाता है, this means that you have compromised that particular password. So an algorithm that uses a 40-bit key has around 1 trillion possible key values, right? And if a 56-bit key is used, then there are approximately 72 quadrillion different key values. So relative to today's computing power, these key sizes do not provide much protection at all. Now see, I have told you in our previous lecture, 100-bit key or larger key would be more secure. If your key length is less than 100, it is not secure in today's world, because we have a very high-end processing machines available nowadays. We have the supercomputers, we have a lot of processing power is available. So the keys like 40 or 56 bit are very normal and they are being compromised within seconds, right? So for today, your key must be more than 100. For symmetric की बात कर रहा हूँ मैं, ठीक है? For symmetric key algorithms, your key length must be more than 100, and I have given you the example in our previous lectures, right? So now we need to understand dash modes. ये तो हमने dash के बारे में पढ़ा कि हम उसको कैसे ब्रेक कर सकते हैं, dash की क्या क्वालिटीज हैं and all these things. I mean, this one was the symmetric algorithm. Symmetric के बाद ये block cipher है, block ब्लॉकिंग के अंदर ये काम करता है। और तीसरी चीज आपके पास ये कि अब हम इसके डिफरेंट मोड्स पढ़ेंगे। आई मीन व्हाट आर द डिफरेंट मोड्स आर अवेलेबल फॉर दिस पर्टिकुलर डेटा एन्क्रिप्शन स्टैंडर्ड्स। सो ब्लॉक ciphers have several modes of operation. Each mode specifies how a block cipher will operate, right? There are different modes of operation of a block ciphers. One mode may work better in one type of environment for specific functionality, whereas another mode may work better in another environment with totally different requirements. So it is important that vendors who employ DES or any block cipher understand the different modes and which one to use for which purpose. Now see, what he wants to say. He wants to say that the DES modes are being applied according to the situation. I mean, in which situation is better for which mode, you need to go for that particular mode, right? So, but for today, what we need to do, we need to, listen, or we need to see that कि आपके पास DES किस तरह से break हो सकता है, right? Understand the different modes and which one is used. Yeah, that's fine, right? So we need to learn about the different modes of DES. Now we will look at 5 different modes of DES, data encryption standards, right? One is called as your ECB, electronic code book. Second one is called as your Cipher blockchain, that is called as CBC. Third one is called as class composition or class what happened? Cipher blockchaining, CBC, Cipher feedback, CFP, output feedback mode, and counter mode, right? So these are the different modes which are being available with DES, and all of them are block ciphers, right? ये चीज आपने अंडरस्टैंड में रखनी है कि हमने DES फर्स्ट ऑफ ऑल सिमेट्रिक एल्गोरिथम, सिमेट्रिक को हमने डिवाइड किया ब्लॉक और स्ट्रीम साइफर्स के अंदर, और अब हम ब्लॉक साइफर्स की टाइप्स पढ़ रहे हैं। द वन इज कॉल्ड एज योर डेस। अब डेस के आपके पास डिफरेंट मोड्स हैं, ठीक है जी, जिसमें हमारे पास ECB, CBC, CFP, OFP और CTR है, राइट? ऑल ऑफ देम आर कॉल्ड एज योर डेस, राइट? सो नाउ वी हैव टू गो फॉर one by one. Electronic code book mode. ECB mode operates like a code book. A 64-bit data block is entered into the algorithm with a key and a block of ciphertext is being produced. ठीक है जी? Now try to understand the working of electronic code book. 64-bit data आपका enter होता है algorithm के अंदर and with a key and a block of ciphertext is produced. I mean in response आपके पास जो output मिलती है आपको वो 64-bit का ciphertext generate करके देता है वो, ठीक है? So for a given block of plain text and a given key, the same block of ciphertext is always been produced. I mean if you have the given plain text and have a given key, द सेम ब्लॉक ऑफ साइफर, अगर आपके पास की और प्लेन टेक्स्ट सेम है तो आपका जो साइफर टेक्स्ट होगा ना दैट वुड आल्सो बी द सेम। दिस इज अ बिग डिसएडवांटेज। बिग डिसएडवांटेज कैसे है कि आपके पास पैटर्न्स क्रिएट हो जाएंगे, जो पैटर्न्स हमने क्रिएट नहीं करने, ठीक है? दिस इज अ बिग प्रॉब्लम विद एनी टाइप ऑफ एल्गोरिथम जहां पे आपके पैटर्न जनरेट हो रहे होते हैं, ठीक है? सो नॉट ऑल मैसेजेस एंड अप इन नीट एंड टाइडी 64-bit block. So ECB incorporates padding to address this problem. ECB is the easiest and fastest mode to use, but as we will see, it has its dangers also. ठीक है जी? अब वो dangers क्या है हमारे पास? A key is basically instructions for the use of a code book that dictates how a block of text will be encrypted and decrypted. ये चीज तो आपने understand कर लेनी है। Key is being used with your plain text that how your data is going to be encrypted and how it's going to be decrypted because it's a symmetric algorithm. ठीक है? Symmetric है तो आपके पास की यूज होगी और की आपके पास डिसाइड करेगी कि आपने किस तरह की इंक्रिप्शन अप्लाई करनी है और उसको कैसे डिक्रिप्ट करना है, ठीक है जी? Now the code book provides a recipe of substitution and permutation that will be performed on the block of plain text. Now the code book is going to provide you the recipe, the set of instructions that how the substitution and permutation, ये भी आपको पता है कि substitution and transposition क्या होता है, they are going to jumble up your data or like that, right? So how the substitution and permutations that will be performed on the block of plain text. I mean plain text को encrypt करने के लिए हमें certain sort of जो आपका algorithm है वो substitution और transpositions perform करता है. तो वो कैसे perform करेगा? That is also being written somewhere in a code book, right? So the security issue that comes up with using ECB mode is that each block will be encrypted with the exact same key and thus the exact same code book. अब इसमें सिक्योरिटी इशू क्या है? सिक्योरिटी इशू ये है कि आपके पास जो ECB मोड के अंदर हर एक ब्लॉक जो है that would be encrypted by using exactly the same key and thus the exactly same code book is being used. इससे होगा क्या? आपके पास सेम टाइप ऑफ साइफर टेक्स्ट जनरेट होगा एंड दैट इज गोइंग टू क्रिएट मल्टीपल टाइप्स ऑफ पैटर्न्स इनसाइड योर डेटा. ठीक है, और जब पैटर्न जनरेट होता है, हालांकि आपका डेटा तो इनक्रिप्टेड होगा, आई मीन दैट इज बीइंग इनक्रिप्टेड, नोबडी कैन सी, बट द पर्सन हु इज एन इविल डूअर और हु इज एन अटैकर कैन इजीली, व्हेन दे आर गोइंग टू कॉम्प्रोमाइज योर सिस्टम, दे वुड check the information or they are going to find the information, they are going to find the patterns, and based on those particular patterns they are going to predict certain sort of values, and from that particular prediction they can easily compromise that particular algorithm. ठीक है जी, तो ये इसकी एक shortcoming है हमारे पास. So two bad things can happen here, right? The one is an attacker can uncover the key and thus have the key to decrypt all the blocks of data. Because of this particular pattern, attacker क्या कर सकता है कि आपके पास key को uncover कर सकता है, and then once the key is being with the attacker, he can decrypt all the blocks of data that is being present inside the electronic code book. Second is an attacker could gather the ciphertext and plain text of each block and build the code book that was used without needing the key. अच्छा जी, अब दूसरी सिचुएशन क्या है कि अगर अटैकर को आपके पास प्लेन टेक्स्ट भी मिल जाता है और साइफर टेक्स्ट भी मिल जाता है, उन दोनों को यूज करके वो इलेक्ट्रॉनिक कोड बुक या कोड बुक आपके पास जनरेट कर सकता है जिसके थ्रू वो कोई भी इंफॉर्मेशन को डिक्रिप्ट कर सकता है, राइट? And there is no key is being required. This is how, these are the two major drawbacks of your electronic code book. लेकिन इसका मतलब ये नहीं है कि we will not be using ECB somewhere. We are actually, if there is some mode, there must be some, I mean to say that implementation of this particular mode that we need to discuss in our future slides, right? So the crux of the problem is that there is not enough randomness to the process of encrypting the independent block. अब solution, I mean conclusion क्या निकला हमारे पास इस पूरे मोड के अंदर? conclusion ये निकला कि we are unable to produce as much as randomness inside our encryption process. और हमारा मेन गोल क्या होता है encryption के अंदर? We need to implement randomness inside our keys also or inside our algorithm also, so that one cannot easily predict that particular value. That's what our, I mean to say that goal is ना, जो भी हम encryption या decryption कर रहे होते हैं, ठीक है, लेकिन इस situation के अंदर आपके पास randomness हम produce नहीं कर पा रहे, ठीक है, I mean to encrypt the individual block. So if this mode is used to encrypt a large amount of data, it could be cracked more easily than the other modes that block ciphers can work in. तो सोल्यूशन क्या है? आई मीन सोल्यूशन तो नहीं कह सकते हम, आई मीन प्रॉब्लम हमारे पास क्या फाइंड आउट हुआ? इफ यू आर इनक्रिप्टिंग योर डेटा बाय यूजिंग इलेक्ट्रॉनिक कोड बुक, if you have a larger amount of data, then it would be very easy for an evildoer to decrypt और compromise that particular mode. ठीक है, अगर आपके पास larger data है और आप उसको encrypt कर रहे हैं ECB से, तो आपका data compromise हो जाएगा, ठीक है. But the next question to ask is why even use this mode? I mean अब आपको पता चल गया कि हमारा अगर larger data होगा और compromise हो जाएगा तो फिर इसको बनाने की जरूरत क्या पेश आई? ठीक है, so this mode is the fastest and easiest one. That is the first advantage of this. So we used to encrypt small amount of data such as different type of pins, challenge response values in authentication process and encrypting keys. अब हम क्यों यूज करते हैं ECB को? कि अगर हमने स्मॉलर अमाउंट ऑफ डेटा को इनक्रिप्ट करना है, आई मीन लाइक पिन्स हो गई, आपके पासवर्ड्स हो गए, आपने कीज को इनक्रिप्ट करना है, आपने चैलेंज रिस्पॉन्स वैल्यूज की ऑथेंटिकेशन प्रोसेस को इनक्रिप्ट करना है, फॉर दैट ECB is the best solution. But if you go for the larger amount of data to encrypt by using an ECB mode, this is not the best solution for larger amount of data. So because this mode works with block of data independently, data within a file does not have to be encrypted in a certain order. I mean, ये हमारे पास block of data को encrypt हम करते हैं, तो data within a file does not have to be encrypted in a certain order. I mean, अगर उसके अंदर different files हैं, तो उनका order matter नहीं करता कि वो किस तरह से encrypt होंगी. They can be encrypted in a different orders or like that. Right? So this is very helpful when using encryption in a database. A database has different pieces of data accessed in a random fashion. If it is encrypted in ECB mode, then any record or table can be added, encrypted, deleted or decrypted independently of any other table or record. अब देखें, ये बड़ी important चीज है understanding करने के लिए. I think you all are well aware about the databases, कि how does the databases works. Now every table in a database is being dependent upon the other table. कहीं ना कहीं से आपके पास प्राइमरी की होती है, ऑल्टरनेटिव की होती है. आई मीन किसी ना एक टेबल का डेटा दूसरी टेबल पे डिपेंडेंट होता है. ठीक है. इन दिस पर्टिकुलर सिनेरियो, अगर आप डिपेंडेंट ब्लॉक्स को इनक्रिप्ट करेंगे, तो जो डिपेंडेंसी है टेबल्स की एक दूसरे के ऊपर, इट माइट नॉट गेटिंग हर्ट, उसको कोई प्रॉब्लम नहीं होगा. ठीक है. आपके इंडिविजुअल डेटा इनक्रिप्ट हो जाएगा, दूसरी टेबल का इंडिविजुअल डेटा इनक्रिप्ट हो जाएगा. जो डिपेंडेंसी है वो इशू नहीं करेगी. ऐसा नहीं है कि दिस टेबल 1 इज डिपेंडिंग अपॉन टेबल 2, सो आई कैन नॉट इनक्रिप्ट टेबल 1 बिकॉज इट हैज द डिपेंडेंसी ओवर टेबल 2. सो इट वुड बी इंडिविजुअल, दैट वुड बी इंडिविजुअल. तो उसके लिए ECB इज द बेस्ट सोल्यूशन. आई मीन इफ यू वांट टू इनक्रिप्ट योर डेटाबेस सॉर्ट of things, then ECB is the best solution to encrypt ECB. I mean to say that databases. I mean database encryption के लिए. ठीक है. In other situation, if you have the dependency between multiple modules, so definitely it would be asking that if you are encrypting this module, it is dependent upon the other module also. So you need to encrypt also that also, because इन दोनों का आपस में relation है. Right? So this is another advantage of ECB. एक तो आपके पास स्मॉलर डेटा, और दूसरा अगर आपने डेटाबेस इंक्रिप्शन के लिए अप्लाई करना है तो यू हैव टू गो फॉर इलेक्ट्रॉनिक कोड बुक. Right? So other DES modes are dependent upon the text encrypted before them. This dependency makes it harder to encrypt and decrypt smaller amount of data because the previous encrypted text would need to be decrypted first. अब देखें, जो बाकी DES के मोड हैं वो डिपेंडेंसी की वजह से आपके पास उसमें ये शॉर्ट कमिंग है कि इफ द टू डेटा आर डिपेंडेंट अपॉन ईच अदर, दे हैव टू वेट फॉर कि जब तक पहला डिक्रिप्ट नहीं होता दूसरा डिक्रिप्ट नहीं होगा. But in this mode, this might not be the case. So because ECB mode does not use chaining, you should not use it to encrypt larger amount of data because patterns would eventually show themselves. अब reason क्या है कि why shouldn't you go for the larger amount of data? Because it would not be used चेनिंग मोड. अब चेनिंग मोड क्या होता है, आगे वाला आपको समझ में आ जाएगा कि चेनिंग मोड क्या होता है. ठीक है. सो फॉर दैट, अगर चेनिंग मोड यूज नहीं होता तो इसमें से पैटर्न बहुत जल्दी आपके पास आइडेंटिफाई हो सकते हैं. एंड वंस द पैटर्न्स आर बीइंग आइडेंटिफाइड, योर इविल डूअर कैन डू एनी टाइप ऑफ मिस्चीवियस थिंग विद दैट पर्टिकुलर डेटा. राइट? सो दिस इज द बेसिक आइडिया ऑफ डेस. ठीक है जी. सो फॉर द डेस अब हम आ रहे हैं साइफर ब्लॉकचेनिंग मोड के ऊपर. ठीक है. आपने ब्लॉकचेन का कॉन्सेप्ट सुना होगा. आजकल एवरीबडी इज टॉकिंग अबाउट ब्लॉकचेनिंग एंड ऑल दैट. एक्चुअली योर ब्लॉकचेनिंग कॉन्सेप्ट यहीं से निकला है, साइफर ब्लॉकचेनिंग मोड. एक्चुअली है तो वो सारी क्रिप्टोग्राफी ना, है तो वो सारी सिक्योरिटी ना. हमने ब्लॉकचेन को क्यों इतना हाइप क्रिएट किया हुआ है कि जी व्हाट इज ब्लॉकचेन is talking about, because it's more secure. But why it is more secure? Because the first block is being dependent upon the second is being dependent upon the third, and then we have certain values which are being jumbled and all that. Actually basic concept यही है अगर आप लोगों ने पढ़ा हो तो. So अब actually this is what the cipher blockchaining mode, which is the basic idea of DES. Right? और DES आपके पास क्या है? Symmetric algorithm है. Right? So in ECB mode, a block of plain text and a key will always give the same cipher text. Right? That's what we have learned so far. कि plain text और key आपको same cipher text देते हैं. This means that if the word balloon were encrypted and the resulting cipher text were HWICSSN, each time it was encrypted using the same key, the same cipher text would have been given. ठीक है. अब अगर आपके पास balloon एक word है, उसको आप encrypt करते हैं by using the same key और resulting cipher text ये आता है, तो अगर आप इस same key के साथ balloon को encrypt करेंगे तो हमेशा आपके पास cipher text value same आएगी. This means that you are going to generate pattern. I mean this we are talking about the ECB mode. So the same ciphertext would always be given. This can show evidence of a pattern, enabling an evildoer with some effort to discover the pattern and get a step closer to compromising the encryption process. That's what I'm saying, right? So pattern generate हो गया तो आप किसी भी सिस्टम को compromise कर सकते हैं. So how does the cipher blockchain mode works? Cipher blockchaining mode does not reveal a pattern. सबसे पहली इंपॉर्टेंट चीज ये है कि यहाँ पे आपके पैटर्न रिवील नहीं होते, बिकॉज ईच ब्लॉक ऑफ टेक्स्ट, the key and the value based on the previous block are processed in the algorithm and applied to the next block of text as shown in the figure. अब इसमें क्या होता है, आपका जो previous block की input है that would be acting as an previous block की output सेकंड ब्लॉक के लिए इनपुट की तरह यूज हो रही होती है, ठीक है. सो दिस रिजल्ट इज मोर रैंडम साइफर टेक्स्ट. साइफर टेक्स्ट इज extracted and used from the previous block of text. This provides dependence between the blocks in a sense of chaining them together. Now see this particular diagram, right? In this particular diagram you have a plain text that is 1 that is being encrypted by using a certain sort of encryption algorithm, or you have a cipher text 1. अब ये जो cipher text 1 है that would be XORed with the plain text 2, and that particular plain text and cipher text 1 would be added in encryption. Again encryption is being applied and you would be getting another cipher text 2. अब cipher text 2 and cipher text 1 इन दोनों की कॉम्बिनेशन से जो चीज बनेगी वो cipher text plain text 3 के साथ जाके ऐड होगी, encrypt होगा and you would be getting cipher text 3. एंड जब वो फोर्थ ब्लॉक के पास जाएगा तो इन तीनों का कॉम्बिनेशन जो है दैट वुड बी गोइंग टुवर्ड्स प्लेन आई मीन फोर्थ इंक्रिप्शन एल्गोरिथम, वो वहां पे जाके कंबाइन होगा एंड यू वुड बी गेटिंग साइफर टेक्स्ट 4 एंड ऑल दैट. So in CBC mode, the ciphertext from the previous block of data is used in encrypting the next block of data. तो जो आपके पास previous block की output होगी वो next block की input कंसिडर करेगी की जाएगी, सही है. So this is where the name cipher block chaining comes from, and it is this chaining effect that hides any pattern. So because of this particular chaining, your patterns are not going to be generated in this particular scenario. The result of one block are XORed with the next block before it is encrypted, meaning each block is used to modify the following block. This chaining effect means that a particular ciphertext block is dependent upon all blocks before, not just the previous block. अब देखें ये बड़ा ही इंपॉर्टेंट कॉन्सेप्ट है अंडरस्टैंड करने का कि लेट्स सपोज अगर आपके पास इसको आप इंक्रिप्ट करने जा रहे हैं प्लेन टेक्स्ट 3 को, इसके अंदर जो इंक्रिप्शन होगी वो आपके पास जस्ट साइफर टेक्स्ट 2 नहीं होगा. इस साइफर टेक्स्ट 2 इज टोटली डिपेंड्स अपॉन साइफर टेक्स्ट 1, और यू मे कॉल इट एज द कॉम्बिनेशन ऑफ साइफर टेक्स्ट 1 and cipher text 2 would be going to encrypt your to combine with your plain text 3, और फिर आपके पास वो cipher text जो 3 होगा that would be the combination of plain cipher text 1 cipher text 2 and then you would be getting the cipher text 3. So all the blocks are depending upon all the previous block, not only on the current block, ठीक है. ऐसा नहीं है कि ये वाला block जो है आपके पास just इस previous block के ऊपर depend करता है. No, this block is being dependent upon this block also and this block also, right? So this chaining, due to this particular chaining effect, means that a particular ciphertext block is dependent upon all blocks before it, not just the previous block, right? So as an analogy, let's say that you have 5 buckets of marbles. Each bucket contains a specific color of marbles: red, blue, yellow, black and green. The first bucket of red marbles, block of bits, you shake and tumble around, encrypt to get them all mixed up. You then take up of the second bucket of marbles which are blue and pour them in the red marbles and go through the same exercise of shaking and tumbling them. You pour this bucket of marble into your next bucket and shake them and all end up. Now this is just an analogy कि आपके पास 5 buckets हैं जिसमें एक में रेड है, ब्लू है, येलो है, ब्लैक एंड ग्रीन है. आप रेड से स्टार्ट करेंगे, रेड को आप मिक्स करेंगे ब्लू के अंदर, उसके बाद फिर सारे को शेकअप करेंगे और फिर रेड और ब्लू दोनों को आप मिक्स करेंगे येलो के अंदर. येलो, रेड और ब्लू का कॉम्बिनेशन बन जाएगा, उन तीनों को शेकअप करके आप ब्लैक के अंदर मिक्स करेंगे और फिर ब्लैक, येलो, ब्लू और रेड का जो कॉम्बिनेशन बनेगा उसको आप ग्रीन के अंदर मिक्स करेंगे. दिस इज व्हाट द एनालॉजी ऑफ योर साइफर ब्लॉक चेनिंग मोड, राइट? So this is how your cipher blockchain works. अच्छा जी, cipher blockchaining mode. When we encrypt our very first block using CBC, we do not have a previous block of ciphertext to dump in and use to add the necessary randomness to the encryption process. If we do not add a piece of randomness when encrypting this first block, then the bad guys could identify the pattern, work awkward and uncovers the key. So we use an initialization vector. अब देखें इस ब्लॉक के लिए randomness कहाँ से आ रही है? From this block. इस ब्लॉक के लिए randomness कहाँ से आ रही है? From here. But what about the first one? ये जो ब्लॉक है इसमें हमारे पास randomness नहीं आ रही. I mean, we have a plain text, it is being encrypted, and we have the ciphertext. There is no any ciphertext that is coming from the backend side और वो इसके साथ mix होके then it is going to be encrypted. No. So this is the point where patterns can be generated. I mean इस point के ऊपर अगर आपका attacker जो है वो pattern को recognize कर लेता है, I mean then it would be chances that he might compromise the algorithm. So for that reason, what we need to do, we need to add certain value that is called as your initialization vector that I have also told you in the previous lecture also. ठीक है. अब initialization vector क्या होता है? The 64-bit IV is zored with the first block of plain text and then it goes through its encryption process. The result of that ciphertext is zored with the second block of plain text and then the second block is encrypted. This continues for the whole message. It is the chaining that adds the necessary randomness that allows us to use CPC mode to encrypt larger files. अब देखें इसमें हम क्या करेंगे कि इस प्रॉब्लम को सॉल्व करने के लिए हमने यहाँ पे एक IV वैल्यू दैट इज कॉल्ड एज योर इनिशियलाइजेशन वेक्टर दैट वुड बी अ रैंडम वैल्यू दैट वी नीड टू जोर विथ अवर प्लेन टेक्स्ट and then we need to encrypt that our data and then you would be getting that particular ciphertext. So this IV value is going to place a randomness inside your system, right? तो यहाँ पे तो randomness आपको मिल रही है, आपका ये ciphertext XOR operation perform कर रहा है plain text के साथ and you would be getting your ciphertext, right? In the same way, this ciphertext would be XORed with the plain text and encrypting it and you would be getting the ciphertext, right? But what happens here? So to overcome this particular problem, we need to add certain sort of initialization vector in the very start of our lecture. I mean, in the very start of our CBC mode, that is going to add randomness to our process. So this is how you are going to, I mean, encrypt larger amount of file by using our CBC mode, right? And finally, the 64-bit. Fine. Yeah, that was the 26th slide. Fine. And 27th आपको क्या बता रहा है? Neither the individual blocks nor the whole message will show patterns that will allow an attacker to reverse engineer and uncover the key. अब देखें इस मोड के अंदर आपके पास कोई पैटर्न जनरेट नहीं हो रहा, राइट? ना इंडिविजुअल ब्लॉक आपके पास पैटर्न जनरेट कर रहा है, ना पूरे का पूरा मैसेज आपके पास पैटर्न जनरेट कर रहा है. सो देयर इज नो वे अटैकर कैन रिवर्स engineer this procedure and try to uncover the key. This is very difficult for them. So if we choose a different IV each time we encrypt a message, even if it is the same message, the ciphertext will always be unique. I mean, every time we are going to use an encrypt IV value, different IV value, definitely it would be creating a different ciphertext, which is a big advantage of this particular mode, right? So this means that if you send the same message out to 50 people and encrypt each one using a different IV, the ciphertext for each message will be different, right? So this is the basic idea of two modes. One is called as your कौन सा था पहला, पता नहीं कौन सा था. Second one is CBC and the first one was ECB, right? The one was ECB, another one is your CBC. So CBC is being used for the larger amount of files in order to encrypt your larger amount of files, और जो आपके पास ECB है, that is being used for to encrypt very small amount of file like your pins or like that.